Welcome back to AP Statistics. This is Dr. Kling, still not affiliated with the College Board. And I'm continuing to discuss hypothesis tests. I'm calling this Hypothesis Test Part 3. And what I'm going to do today is make up an example, do the test, and then discuss a bunch of issues related to the test that are important to keep in mind. So the example will be, we'll take a sample of 400 graduates, again this is all made up, of Ivy League schools, and let's say 600 graduates of state schools, and I'll make up the average salaries and the standard deviations. Okay, so for the Ivy League schools, I'll say that the average salary is $62,000, and a standard deviation, a sample standard deviation of 21,000. And for the state schools, I'll say the average is 57,000, a standard deviation of let's say 18,000. Alright, now the question is, are Ivy League salaries significantly higher? And we use alpha, which is our cutoff point. It's something that's selected by the investigator to measure statistical significance. And we'll set that equal to 0.05. So we're asking is, when we do this test, if we get a p-value less than 0.05, we will say that there's a statistically significant difference. If the p-value is greater than 0.05, then it's not significantly different. Okay. Alright, so now I'm going to do that test. It happens to be something called a two-sample t-test, which we'll go over more later. Don't worry about this so much, but I'll show it to you if I can remember how to do it. So we want to do stat, and then we want to go over to tests, and then we'll go down to two-sample t-test. And then we have a bunch of inputs. We'll input stats, and then we'll go down and we'll put in the X1 bar is the mean, let's say, for the Ivy Leagues, which was 62,000. S1 was the standard deviation, which was 21,000. And then I think we said we had 400 of them. That's our N1. And then we have our non-IVs, which I think we said was 57,000. And then we have the standard deviation, which I think, what did I say that was? 18,000. And then the number in the sample, which was, I believe, 600. And then let's just keep going down. What else do we need? Okay, so our alternative hypothesis is that mu1 is greater than mu2. That is that the IVs earn more. The null hypothesis is that they earn the same. And let's keep going down. This pooled thing is, do we assume the same standard deviation? And the answer is no, we don't assume it. And then let's calculate and see what we come up with. Hopefully we'll get an answer at some point. Okay, yes, we got a... The important thing to look at is the p-value, which is here. It's 5 times 10 to the minus fifth, so it's a very low p-value. Alright, so we get a p-value equals 5 times 10 to the minus fifth, and I think, what is that, 0.00005? Is that right? There might be another zero there, but anyway, in any case, it's very small, so it's definitely a statistically significant difference. Okay, so I think I mentioned, but if I haven't, that alpha is called the significance level. So we would say that our result is significant at the 0.05 level. In fact, we could say it's significant at a 0.01 level. In fact, we could say it's significant at a 0.001 level. Now remember, this is all made up data. I don't know what actually happens in the real world. So what does statistical significance tell us? One thing it does not tell us, so statistical significance does not tell us that the difference is important. What we said was that there was this $62,000 mean for the Ivies and a $57,000 for state schools. Now, if the if the Ivy League tuition is let's say $40,000 more per year, that is, if they charge $40,000 more in tuition, and you're going for 4 years, it would take you a long time to make back that tuition difference at a $5,000 difference. So this $5,000 difference may not be important, even though it seemed to be very significant statistically. So statistical significance is not the same as quantitative importance. That's an important point. Hang on a second. Okay, so now I want to walk you through the steps in doing a hypothesis correctly, or doing a hypothesis test problem, the sort of problem that you'll be given, like on the AP, correctly. So the first step, step 1 in words. So that would be, in this case, the parameter of interest is the salary. So mu1 is the salary, the true salary of Ivy League graduates. Mu2 is the true salary of state school graduates. And now what we're really interested is in mu1 minus mu2, which is the difference between the two. Okay, the second step is state HO and HA. And there we will say the null hypothesis is that there's no difference. Mu1 minus mu2 equals 0, or alternatively mu1 equals mu2. The alternative is that the Ivies earn more, so mu1 minus mu2 is greater than 0, or alternatively mu1 is greater than mu2. Then we want to state the type of test that we're going to use. State the type of test. In this case, we're using a 2-sample t-test, and in later lectures I'll explain why we selected that and what some of the other choices are. So 2-sample t-test. Like that. 2-sample t-test. Verify any assumptions that are needed. In this case, I'll just tell you that we have relatively large samples that we're working with, and that's really enough to verify the assumptions in this particular case. If we had smaller samples, we'd have to look at the data a little bit more carefully. 5. State the inputs. If you're doing the calculator, give the inputs to the calculator. So that would be remember we had our x bar 1, s1, n1, and so on. Finally, give the results. In this case, our p-value was that 0.00005. Then draw a conclusion, and we reject H0. And if you remember nothing else from this lecture, remember that we reject when the p-value is less than alpha, and we fail to reject when the p-value is greater than alpha. Do not think that a high p-value is strong evidence. It's quite the opposite. And finally, state conclusion in words. And the conclusion in this case is that the Ivy salaries are higher than state schools. And again, we don't know if that difference is quantitatively important. It's statistically significant, and here's another thing to remember. Statistically significant, I hope you understand that abbreviation. Statistically significant means that the results are not likely due to sampling error. That is, to the quirks of our sample. It's not likely due to chance. We're willing to believe that these results hold in the population. And that's it.